Alright, so now we're going to talk about soil erosion. We just finished soil classification and the soil profile and different controls on soils. So, soil erosion is the removal of the topsoil, which is a serious environmental problem of which many people do not realize or know that it's happening. This may be because even though a lot of soil is eroded every year, to our eyes, there's still a lot of it left. Nevertheless, the loss of this topsoil, which is very fertile, is a growing problem as human activities disturb more and more of Earth's surface. The soil erosion overall is a constant natural process, and it is natural again. So it is part of Earth's recycling of materials. And erosion is mostly driven by, again, agents such as water and wind, and sometimes ice, but mostly water and wind. Out of the two, water is the bigger of the two agents, so about twice or even a little bit more, or greater, I should say, than wind is. So, as an example, every time that it rains, raindrops will dislodge the particles in the soil, like you're seeing in the top right image. As raindrops accumulate, a thin sheet of water develops, and they flow across the surface as sheet erosion. Afterwards, the water flows in this thin and unconfined sheets for a short distance. These threads of currents will develop tiny channels, which are called rills, like you're seeing up here on the middle image, I guess, and also down here in this bottom image. So again, rills. Once rills kind of accumulate together, they make this deeper cuts within the soil, and those are called gullies, like the one over here. And they're again created by the rills either getting together and enlarging, or just simply flowing down into a previously made one. And then from the gullies, the water and the particles that it may carry flow into the stream, where they get transported and eventually deposited to their new location. In many instances, this new location tends to be the ocean, but sometimes they tend to just be river point banks, or just simply near dams or lakes. So it depends, but in many instances, this last new location is the ocean. We know soil erosion is the ultimate fate of practically all soils. In the past, soil erosion rates were slower than today's, though, because much of the land was covered by shrubs, trees, grasses, and other plants that today are covered by buildings and roads and agricultural lands and whatnot. But human activities, again, such as farming, logging, and construction, will remove and disrupt this natural vegetation. And since humans have been around, they have greatly accelerated this rate of erosion that now has no plant stability in the soils to keep them, settled, and hence being less able to be carried by the wind and the water. Erosion varies greatly by location, and it depends on all the factors that were also important towards soil formation, such as, again, climate, parent material or rock type, the time, the topography, and the living organisms on top. In certain areas, the erosion rates can be measured by how much sediment is carried by streams into the ocean. And these rates have been estimated throughout the world to have been about 9 billion metric tons before, or I should say 9 billion metric tons per year before humans. And now that us humans are around with our current practices, they're estimated to be about 24 billion metric tons per year. So that's about 2.5 times, or more than 2.5 times greater than the amount of soil that was eroded before us. So that's concerning. Overall, flowing water, is responsible for about 2/3 of the erosion, at least in the U.S., and wind is responsible for most of the remaining third of this erosion. Wind will affect areas that are typically low in moisture and that have low vegetation cover, areas that are exposed. Water acts on all of the soil types where it is present, so most of them. This picture that you have right here on the right is a picture of the Great Plains in Texas, Oklahoma. Actually, I don't know where this specific picture is taken, but the area that was affected was in like the corner of Texas, Oklahoma, New Mexico, Colorado, and Kansas, kind of where they sort of meet. So this area was called the Dust Bowl of the 1930s. What happened during the Dust Bowl was that dust storms plagued these Great Plains. Due to the size of these storms that were caused, as you're seeing in the image, the region came to be known as the Dust Bowl. And the period itself of those times was called the Dirty 30s, as it happened in 1930s, and it was all very full of dust. This Dust Bowl was caused by the increase in agriculture in the area some years before the dry, windy time. So the increase in agriculture happened not too long before, and it happened due to a wet period. So people got, encouraged to do more agriculture. In those years when this started, it was all fine because it was wet enough so that water would accumulate on the soils and keep them grounded. However, once the 1930s hit, the area went back to its usual conditions of windy and sort of arid lands. And so, because of the removal of soils, or not removal, but the disturbance of the soils during agriculture, they were a lot easier for wind to carry, and so they made these gigantic dust storms. And overall, this resulted in severe soil loss, crop failures, and also in some economic hardship for all the people who relied on them and who lived in the areas. The soil erosion is also a problem when we consider the next step after erosion, which is soil deposition. If there is, for example, an extra supply of soil, which is what is happening with the erosion, it will require a new place to reside, so a new deposition location. So by the erosional agents, the sediments usually get deposited in places such as lakes, rivers, streams, and oceans. So a very good example of this problem is the deposition observed above. This deposition happens in the reservoirs where dams are in place. So because of the dam being in place, the stream that is carrying the sediments starts to slow as it is approaching the dam because the overall gradient becomes lower, and as we'll see in chapter 13. And the sediment begins to settle and drop into the bottom of the entrance here to the reservoir. So it gets deposited. If this continues for a while, the amount of sediment at the source increases dramatically, which makes the reservoir smaller overall because more soil is occupying the previous space that the water used to occupy. So eventually it will fill up faster and it will possibly overflow, or it will simply cause problems downstream if the dam is open to release the amount of water and relieve the high sediment deposition consequence that we're seeing. So once the reservoir fills, there will be a lack of water storage, as I basically just said. There will possibly be flood downstream as they have to open the gates, and there will be a surplus of energy when it is not needed, and possibly a lack of it when it is needed. And there will be, for example, changes in the reservoir's biodiversity as well due to the increase in the sediments. So there's a lot of changes that ongo here, given two actions of humans. One being the dam emplacement, but the second one being all the erosion that we are causing, or that we are allowing to happen due to our practices. Another problem with current practices and soil erosion being the carrier of these are herbicides, pesticides, and fungicides that are chemically bonded with the sediments and are hence carried downstream with them. So again, these bond with the sediments resulting from agricultural practices and then are carried downstream on the water channels. So overall, the herbicides, pesticides, and fungicides get carried downstream as well. These types of substances in the long run kill aquatic life wherever the sediment is indeed deposited. And another problem occurs from the bonding of fertilizers with the sediments. So fertilizers also bond with the sediments and they get carried downstream. Downstream, once the sediments get deposited, they will the fertilizers will react or will be left there, and so algal blooms will occur, which provides perfect conditions for one single species to prosper in a way that is not natural. So to combat some of the problems that are caused by soil erosion, there are a few things that a few farmers and homeowners have started to do across the globe. Amongst these, some of them are things such as growing food organically without the need of fertilizers or pesticides or fungicides and whatnot. By doing this, there is a reduction in the secondary effects seen from the soil erosion, as we discussed in the last slide. So by growing that organic food, there's no need for those additional substances that bond with the sediments. Others have decided to do contour plowing, terraces or terracing, and also applying windbreaks. So all of these three methods reduce the erosion overall. So again, the first one just reduces the secondary effect from erosion, and then those three, contour plowing, terracing, and windbreaks, reduce the erosion overall. So contour plowing, what it does is it doesn't allow for water to accumulate into rills and gullies as easily, and for wind patterns to erode only so much at one time, depending on the direction that the winds are blowing. So it does make it a little harder for those erosional agents to in fact erode. Terracing allows for any precipitation to actually percolate in each of those terrace steps, rather than the water that would flow rapidly downhill on such a steep slope. If it were to flow downhill, it would barely percolate on the top part of the slope, and so a lot of it would end up on the bottom part of the slope when it begins to get shallower. And lastly, the windbreaks are lines of trees that control any wind-driven erosion from the adjacent soils. And these are seen, for example, a lot in near the Columbia River. So in Oregon and Washington, you see a lot of these windbreaks. All right, so I did not cover section 6.8 of your book on this lecture, nor will I ask it during the exam, but it's worth the read, so I encourage you to check it out. And with that, we finish chapter 6, and we will move into chapter 7 for our next lecture. I hope this was a good and understandable and informative lecture. And as always, ask me any questions if I can answer, or I will try to answer any of your questions and help you however I can.